Welcome everyone. I'm excited for this chance to share with you a tool we built to make online teaching more engaging. This tool uses virtual avatars for both instruction and student response during online teaching based streaming video scenario. My name is Sang-Woo Jun, and I'm an assistant professor at the Department of Computer Science at the University of California, Irvine. Our motivation for building this tool was the following. Due to COVID-19, a large number of classes we were teaching in person had to urgently move to online teaching, with next to no time given to research or to prepare effective methods for retaining engagement or attention of students during online teaching. Many classes moved to existing video conferencing tools such as Zoom, thanks to their wide availability, scalability, and ease of transition. However, we discovered that video conferencing tools by themselves were not very effective for remote teaching for a variety of reasons. First, in a video conferencing-based class, instructors typically share their screens, showing instructional material such as presentation slides. The instructor, him or herself, is neither not visible or fixed to a corner of the screen. We noticed that this was not effective in retaining student attention compared to having the physical presence of the instructor, pointing to the slides and guiding attention. Second, compared to an in-person setting where students can semi-anonymously give response by raising their hands or voicing an agreement, response in video conferencing-based classes typically lose anonymity and becomes the focus of the class. The overhead of turning on the camera or mic to speak is also a big hurdle, according to students. Our current solution to this problem is using avatars for both instructors and students. For the instructor avatar, we built a custom tool which parses the instructor webcam video and runs an OpenCV facial landmark detector in order to make this avatar, which you are seeing, mimic the instructor's head movement and expressions, as you are seeing right now. This way, the instructor can also easily move the avatar across the screen to act as a natural pointing device and guide student attention. On the other hand, the student avatar aims to allow anonymous response, lowering the hurdle of providing responses to teaching material. Students are given a web interface with one or more buttons they can click to initiate a small avatar to move up from the bottom of the lecture screen, like you see on the bottom of this screen. The resulting swarm of avatars, if any, are visible to both instructors and students as they are overlaid onto the teaching material video stream itself, and it becomes a useful tool to quickly gauge consensus, excitement, or levels of understanding by the students. As mentioned, the avatar software reads the video stream from the instructor webcam and performs facial landmark detection using a neural network model. This information is used by the avatar software to animate the instructor avatar, and the students interact with a Node.js server which sends the student responses to the avatar software for rendering. The resulting avatar animations, both for instructor and student avatars, are overlaid onto the instruction materials themselves via the open source Open Broadcaster software, or OBS. And the resulting video stream is streamed out to the students via a conventional video conferencing tool such as Zoom. Here, we see an example screenshot from an undergrad computer architecture lecture with students voicing acknowledgement, causing a swarm of avatars to show up on the video stream at the bottom. We evaluate the benefits of this approach using a small anonymous poll after the end of the course. When asked for the preference of the instructor avatar compared to a static instructor video, the response was generally positive, showing more than half the students responding with a very positive response, with only a small set of indifferent responses. When asked for comparisons against having no instructor videos at all, the response was also generally very positive. For the student avatar-based anonymous feedback, the responses were also generally positive, with more than half the student responding with a very positive response. We noted that there was one response that was very negative, but the student did not list why. We plan to continue research into this area to determine if there is a reason. The individual responses from students also included positive feedback, including how the instructor avatar was useful as a pointer, and how they liked the creativity of avatars being used for lectures. We think that this system has had a beneficial impact on the quality of student education during the pandemic. However, we also hope that we can also quickly go back to a safe in-person teaching, removing the need for this tool at all. Thank you.